So today I'm here in front of you to start with the new topic of the software engineering. Today I will cover these models, the life cycle models. One is the waterfall model. Second is the prototype model, then the evolutionary model and the spiral model. So today I start first of all with the waterfall model. So after going through this unit, that the first part of today's lecture, you should be able to gain an understanding of classical waterfall model, iterative waterfall model, and differentiate between both. So first we start with the classical waterfall model. So just I will tell you about this classical waterfall model. Classical waterfall model. So what happens, as you have already in previous lecture we have done the software development life cycle, so SDLC. So it had different phases. So those phases were feasibility study, requirement analysis, design, coding, testing, and maintenance. So actually the classical waterfall model is nothing. It depicts all the phases of the software development life cycle. So it was in the previous lecture we did. First of all, there was the first was analysis of the requirement, then the design, then the implementation, then testing and maintenance. So classical waterfall model basically exhibits all the phases which are required in a software development process. So just see, first of all, it has got the feasibility study. So before launching our any software product, the implementation of any software project, I will say, first feasibility study is made whether is it feasible to develop such a software product or not, whether it is beneficial, what are the basic objectives of developing this product. So whether it will be able to find the market for this particular product. So shall we make it or not? First decision is taken. Will it be feasible to make it or not? All the requirements. So we have to see if we find that in an overview of that, yes, it is feasible to make this particular product. Then we come to the next phase where we go for a requirement gathering. We gather all the requirements, either it is a formal requirements or either it is a non-functional requirement, functional and non-functional requirement. So after feasibility study, we have a requirement analysis phase. Then comes very important thing. And in requirement analysis phase, one important document is prepared, which is known as SRS. So when we will discuss this phase as a whole chapter, then I will tell you what is SRS. Then come to the design phase. Very important, the design phase. Here the actually the architect of your software product is designed. The blueprint is prepared here. So when we will come to the design chapter, you will see there are different approaches of designing, like certain function point designing, feature point or feature metric designing, and object oriented designing. So we will see all the designing in a types of designing, like user interface designing, the main designing of your software product. All is structured designing, structured architecture design. All the things are covered in a design, and the concept of cohesion and coupling will also be covered here only. Then we come to the next phase, coding. So coding is very important, where whatever the algorithm, whatever the thing we have written, what are the steps we are written, that have to coded in a particular language. So whole coding is done here. After that, before launching your product in the market, we have to test for its correctness. So that is done in the testing phase. So in testing, during testing phase, what is done, different categories of testing is there, different approaches of testing is there. We divide the whole software into the small modules. So modular testing, that is the unit testing, is done. Then one by one we arrange this together, that is known as the integration testing. And at the end, when the whole integration process of all the units is done, then we go for a system testing. Then there is another approach of testing, that is black box testing, and the white box testing, that is also carried out. So there, along with this, there are different types of testing like mutation testing and all that, and how to prepare the test cases, how to generate the test cases, how to make the test suits, that will be covered in the testing chapter. So after testing, the next phase come is the maintenance, that we deliver the software to the users, and even after delivering, the continuous maintenance is required time to time. Either it is a adaptive maintenance, perfective maintenance, or corrective maintenance. That are the different types of maintenance. So maintenance is very important aspect or very important phase of any software product. So this is the main classical waterfall model. But what is the problem here, that we will see next. So before coming to the problems, what are the relative efforts for the phases? You will see. So phases between the feasibility study and the testing is also known as the development phase. So among all life cycle phases, maintenance phase consume maximum effort. That is after delivery. So maintenance phase consumes the maximum effort. You can see the graph along with. So what is the effort required in the requirement phase, then in the design phase, coding phase, testing phase, and the maintenance phase. So during the development phase, testing phase consumes the maximum, but in the overall software life cycle, the maximum time is required by the maintenance phase. So classical water model is idealistic. So where it is suits, where the classical waterfall model suits, it suits in the area where we assume that requirements does not change. Requirement does not change with time. So all the applications where once the requirements are laid down, then it does not change with the time. For those applications, for those systems, the classical waterfall model is the best model. Or you can say where the requirements are frozen. So once the requirements are set, then it is frozen. On those criteria, the classical waterfall model is the best model. So it assumes that no defect is introduced during the development activity. And in practice, what happens? Actually, defects do get introduced in almost every phase of the life cycle. One of the limitation of classical waterfall model is its assumption. It assumes that requirement does not change with the time and defects do not creep in any phase. So due to this, the most important disadvantage of this phase is there is no feedback. So there is no feedback. Once one phase is over, we have to move to another phase. We cannot come back to the previous phase. So whatever has to be done in any phase, it has to be done once. Once we leave that particular phase, we cannot return back to that particular phase. So this is the most important disadvantage of waterfall model. But why we use the waterfall model? Because it is the most simplest form of all the life cycle models, and actually it is nothing but it is the idealistic implementation of the all the phases of the software development life cycle. This is the importance of waterfall model, that is the classical waterfall model. Next. So once defect is detected, we need to go back to the phase where it was introduced. So redo some of the work during that and all subsequent phases. But in waterfall model, we cannot do this because there is no feedback path. So, but we want that our software should be defect free. So if we found in a later stage that the defects are there, then there must be some provision that we should go back to the phase that we have already left, but now there is a problem. We have found some defect, we have found some error. So there should be some feedback path in a classical waterfall model. So this need in a classical waterfall model gave rise to the new waterfall model, which is known as the iterative waterfall model. So this is the iterative waterfall model. So you can see very important thing. The diagram is almost the same of classical waterfall model. So like this is the diagram. But what is the change? What is the change? Change is this thing. We provide the feedback here. So this is the change here. The provision of the feedback. So just see in a diagram in a presentation slide. So this is the feedback is present. So if when we leave this phase and move to the next phase, and after this we move to come and we found that there is some defect or bug has crept into the previous phase. So then also it is possible from moving from this phase to this phase. And if we have made some changes in this phase, then the corresponding changes are to be made in this phase also, and then we come back to the this phase from where we left. So this is the main thing which is advantage of the iterative waterfall model, which removes the basic and the foremost disadvantage of the classical waterfall model. Yes, next. So what happens in iterative waterfall model? Error should be detected in the same phase in which they are intersect. Generally, what should happen that when we are working on this phase, any phase, you can say phase one, that is the requirement phase, then all the errors before leaving this phase, actually, all the errors should be detected here itself. Then we should remove all those errors and then we should move to this phase. But due to the dynamic nature of the whole SDLC, some errors even creep in the afterwards when we leave the phase. So what should be done, that I have already told what should be done. So if a design problem is detected in a design phase itself, suppose this here we are dealing with the design phase. So if any problem is detected here itself, the problem can be taken care of much more easily. So what is, you can say, good thing if the problem is detected within a phase where we are working at present, then it is very easy to take care and resolve this problem. Then say if it is defined at the end of the integration and system testing phases, we are in a design phase, the problem remain here, but we are working on a testing phase. So what should be there? Now we should, through this feedback, we should move here back to the design phase, because now we are at the testing and integration phase, but the problem was defined or has been detected in the previous phase, then we should move back. So rework must be carried out not only to the design, but also to the code and test phase. Why? Because whatever the change has been made in the design phase, so corresponding changes has to be made in a coding phase, and corresponding changes has to be made in a testing phase. So this is the procedure which is followed in iterative waterfall model. So there is a term that is phase containment of error. The principle of detecting errors, as I was talking about, as close to its point of introduction as possible. It is known as phase containment of errors. So if we have a good team of the software developers, then there will be this characteristics will be present in a life cycle model, that is the phase containment of errors. So if experts are there, they are known to handle the errors right at the point where it occurs. So iterative waterfall model is by far the most widely used models. So almost every other model is derived from the waterfall model or the iterative waterfall model. So this was basically about the waterfall model. Before moving to the next model, that is the protocol model, uh, just I will go through the summarization of the waterfall model. So in waterfall model, we have two types of you can say versions, like classical waterfall model and the iterative waterfall model. But in classical waterfall model, the disadvantage is no feedback path is available, which is this disadvantage is removed in a iterative waterfall model. So now I will go with the protocol model. So now I start with the protocol model. So what is the protocol model? Just we will look onto this model after we have done the waterfall model. So just protocol model. So before coming to this, so I will just tell you what is the importance, what you will gain after this part of the lecture, that is the protocol model. What you will gain from this part of my lecture. So you will come to know the understanding, you will have a better understanding of what is protocol model about. You will know about the advantages and disadvantages of this protocol model. So what is basically a protocol model? Just understand, you can also read through the slide which is present in front of you, but just understand what is this. There are actually the two, just note that there are two other names of this model. One is known as OA model and another is known as throwaway model. So why these two names to this model, that is the protocol model? What happens actually when we make a software product and there is always doubt that what we are doing in every stage, whether we have done it good or not, whether it will be acceptable in a market or it will not be acceptable. So many questions arise through our mind. So we want that if we can get the feedback of the customer right now before launching to the in a market, that whether what we have made or what we have done up till now, we are going in a right direction or not. We want to check it. Then this type of to give the answer to give the type of questions in our mind, we have developed the prototype model. Just read out. A prototyping model suggests that before carrying out the development of the actual product, a working prototype of the system should be built, and it should be with the few features, but a working prototype should be made and we should implement that, and then we can see whether it is going through or not. We can say some examples, some small, we can say part should be made and we can see. So a prototype is a toy implementation of the system, not the actual system. Just the another you can say toy copy of the system. So prototype is working model of the software with some limited functionality. Not all the functionalities are there. All the capability is not there. With very few capability, we make a protocol of the final product, which was desired. So we make its protocol, we find whether it is working properly or not, or whether we are going in a right direction or not. If we find success in a prototype or the toy model what we have developed, then it gives us idea that we should move in a which direction. This is if it is all whatever the desired things we thought of, if it is giving all the desired things, means our designing part, our development, you can say direction is going very well, and we should move into that direction only. If the results are not as desired, then there is a question mark on our development style. So we should find the new way of developing the software product. So prototyping is used to allow the user evaluate the developer proposes and try them out of before implementation. So what happens, what it is saying is that we prepare a small toy model, then we throw into the our friendly users. We provide this toy model or prototype to our the friendly users. They work upon, they implement, they use this software, and they give us the feedback. They give us the feedback that these are the things which are good and this is what is the shortcoming. Then if the things, what are the things we are looking for, it is giving the same result mostly, then the direction is right. If we get the feedback from the customer, that friendly customer, that it is not good, most of the feedback is negative, then we should change the direction of the development. So this is the mean, and we throw away this to the friendly users. Therefore, it is known as the throwaway model or the toy model. So these two names are given to the protocol model. Next. So how does the protocol model look? What are the different phases? First is requirement gathering analysis. Gathering phase is there and analysis design is always there. Then the development phase, testing phase, implementation phase, and the maintenance phase. So phases are all as we have done in the software development life cycle. So all the phases are there. Just see the diagram of this thing. I will just make in a board also what happens. So first of all, just see requirement phase. It is done in a full-fledged way on the basis of the requirement. Very quick design. Very quickly we design a protocol of the actual software. Very quickly design the protocol of the actual software. We design the protocol. Then, so we made the protocol, build protocol. Then what is done? We give this protocol, we throw away or provide this protocol to our friendly customers. We provide it to the friendly customers. They work upon this, they give the feedback, and on the basis of the feedback, we keep on continuously refining. On getting the feedback, so we go for a refinement process. And again, we quickly design the new protocol which incorporates all the suggestions given by the friendly customer. And again, this is continuously. This process is in a loop. This process is in a loop. And once we find the satisfactory result that whatever the final product should do, so we have made such a protocol, then we move from designing phase to from this phase to the next design phase as suggested in a SDLC, then implementation, then testing and maintenance. So then we move to the development of the whole product as a big product of the software. So this is the change from the regular waterfall or the iterative waterfall model. So this is the change. So these steps are gone again and again. Requirement is done once, then quick design, build a protocol given to the friendly customer, get the feedback, then incorporate those suggestions as a feedback and design a new protocol, quick design, very quick. Then again, same process is done until the satisfactory results are given, are received for the given protocol. Then we move to the full-fledged design and other phases of the model. So this is what happens in a protocol model. So just go through this. So requirement gathering and analysis is done. A prototype model begins with the requirement analysis, and the requirements of the system are defined in detail. The user is interviewed in order to know the requirement of the system. Is the client. Here the user is the client who needs the software product. Then quick design is there. When requirements are known, a quick design for the system is created, as I have already told here. So it is not detailed design. It includes the importance and the fundamental aspects of the system, which gives the idea of the system to the user. Next. So it is sent for the customer for the evaluation of the prototype. Then customer gives the feedback and the prototype refinement phase continues until we find the such a prototype which is the just near to the final project. All the requirements are there. So once the user evaluate the prototype, it is refined according to the requirements. When the user is satisfied to the developed prototype, a final system is developed based on the final prototype, which is developed by the iterative method. Means we design the system according to the final prototype after the implementation, testing, and the product to find error at the last. We maintain the system in the maintenance phase. So what is the need for the protocol model? So prototype model or the protocol type model provides us a method to examine design problems and evaluating the solutions. Though the prototypes are not self-explanatory, so it is clarifying what aspects of the prototype correspond to the eventual artifact and what don't is a key part of the successful. So if we find some, we can say unwanted results. So here we decide that this should not be carried out in a next protocol, next toy design. So this is the important thing. We can come to know what should be carried forward, should be done in this way only, and what should not be done in this way, what should be neglected or stopped. The development of the prototype model is expensive because many a times we stuck into this thing. So we again make a new protocol, we make a new protocol, we keep on making a new protocol until the satisfactory result we get for a prototype, for the protocol. So sorry, prototype. The development of the prototype model is expensive, but it is a good model because it satisfies all the requirements of the customer. So we verify that all the requirements which the customer has given in a requirement gathering phase, now the whatever the protocol we have or whatever the prototype we have developed, is it satisfying all the requirements, yes or no? If the answer is yes, then we move to the detailed design. So advantages of protocol model you can go through. It provides a working model to the user early in the process, enabling early assessment and understanding, and also increasing the confidence of the user about that particular product. The developer gains the experience and insight by developing a prototype, thereby resulting better implementation of the final product and which satisfies all the requirements laid by the users. It helps in reducing the risk and associated to the project. The prototype model serves to clarify requirements which are not clear, hence ambiguity, and improving communication between developer and the user. This happens in a prototype models. But still this model has some disadvantage. So in the next slide, I will show you the disadvantages. So if the user is not satisfied with the developed prototype, then a new prototype is developed. So this process goes on until a perfect prototype evolves. Thus, this model is time consuming and expensive. Time consuming and expensive. The developer loses the focus of the real purpose of the prototype and compromises on the quality of the product if he wants to come out of this loop. For example, she may apply some of the inefficient algorithms or inappropriate programming language and used in the developing the prototype. So this is all about the prototype model. This is all about the prototype model. So here I will stop that we have discussed the prototype model. So next disadvantage, this is already done. So the next part of today's lecture is the next model, that is the evolutionary model or the incremental model. So this model is evolutionary model or incremental model. So after going through this part of the presentation, you will be able to know about what is basically the insight into the incremental or the evolutionary model, and when we should use this model, what are the advantages and disadvantages of this category of models. So evolutionary model, so it is also known as incremental model. So what happens? The system is broken down into several modules which can be incrementally implemented and delivered. First, we develop the core modules of the system. Then the initial product skeleton is defined into the increasing level of capability by adding the new functionalities in successive versions. Stop. So I will tell you about what this is here. So what happens? Suppose this is actually the software product. This is actually the software product, and you divide this software product into small modules like module 1, module 2, module 3, module 4, module 5 and module 5 broken down into the small modules. Then you find out features that module 1, module 3, 2 and module 4, they compromise mostly all the features, mostly 90% or 80% features of your whole software product, and they are the, you can say, the features which are required in the beginning itself. Then later on we can add more features into your software. So what you do, you start developing first of all M1 plus M2 plus M3, sorry, M4 in a first phase, and you release the software in a market. Later on, you add M3. Later on, you add M3. Later on, you add M5. Later on, you add M6. So once you add M3, then it, suppose first of all you release with these features of M1, M2, and M4. So let it say version 1. So it is a version 1. When you add M3 new functionalities which are lied in M3, it will be denoted as version 2. When you later add M5 also, version 3, then new version 4. So you find that you nowadays you get many Windows operating system and any software with the different versions. Android, you are getting the Android with the different version, and each successive version, some additional features are added to the previous version and outdated features are removed from the version, and you get a new version. So that type of development of a software product in a different versions is known as the evolutionary model. In terms of book publication, you get the first edition, then second edition, third edition, fourth edition of books. So these are the example of the evolutionary model, or the incremental model. You add on features in new version or the new increment that you give to the customer. It is not only the adding, some outdated features are removed from the previous version also. So this is what which is carried out in a evolutionary model. So I think you understand what is the outview or the overview of the evolutionary model or the incremental model, because we evolution, why the name is evolutionary, because first of all the basic things are provided. The model or the product evolves first of all with the basic necessities, with the basic features. And why it is known as incremental model, because we keep on adding new features into the previous one and provide the new version of that particular product. Therefore, these two names are given to this type of model, that is evolutionary or the incremental. So successive version of the product that I already told you. You are getting the successive version of the product. So successive functioning system capable of performing some useful work. A new release. So you make a new release which may include new functionality, new features. So also existing functionality in the current release might have been enhanced. Sometimes the new features, the new function is not there, but the already present function, they can be enhanced. So this is also the evolutionary model. So in the next version, the functions are same, but the functions are enhanced. This can also be. Just see example. There was first version with A. In second version, A is there plus B, and in the third version is A plus B plus C. So this type of adding the functions in an increment manner or adding the new features in an incrementally manner, this model is known as evolutionary model or the incremental model. So in incremental model, the whole requirement is divided into various builds. So various versions you can say. Each module, that is the independent units, passes through the requirements, design, implementation and testing. So suppose M1, M2, M4, first version. So they all go through design phase, implementation phase, and testing phase. Afterwards, M3, this module, it itself goes through design phase, testing phase, implementation phase. When it is added to this, then again whole thing is there. Then we had M5. So M5 also goes through requirement phase, design phase, implementation phase, and testing phase. And last was the M6. It also goes through those phases. So the incremental build model is a method of software development where the product is designed in increments, implement and tested incrementally until the product is finished. All the features are there. So you can see different versions of your different operating systems. So just see the whole requirement is there. Then you provide with the main requirement in the build one. Later on, you add more features from the pool of the requirement, and they are incorporated in build 2 and added in build 1. And last, all the left features from the whole requirement pool, they are added in a build 3 and they are added to build 1, build 2 and build 3. So this process continues until the whole the requirements which are present in a pool of requirements, they are incorporated into the final version. So this is the incremental model. Just see, go through this picture. So in the first build or the first version, only the outline is there. Then in the second, only the upper part. In a third, little bit of the hands are shown. Then in a fourth, the whole body is there. Then in the fifth, more clarity is there with the background also. And in the sixth, the overall picture is there with the background and the foreground. So just in increments. So when to use this incremental model? Mostly such model is used in web applications and the product-based companies, where you release the first version of the product, then second product, and Third, as I told you, the operating systems. This model can be used when the requirement of the complete system are clearly defined and understood. Then only in the beginning you understand all the requirements, but in the first hand you provide with the basic requirements, then you add on features. Major requirement must be defined. However, some details can evolve with time. So major features have to be given in a first thing. If the operating system is there, so all the different types of managements which are required in operating system, they have to given in a very first version itself. There is a need to get a product to the market early, and when we find that we should release the product very much and additional features can be given afterwards, we want to launch the product due to competition in a market very early, then this type of model is built. So advantages is generate working software quickly and early during the software lifecycle. This model is more flexible, less costly to change the scope and requirement. It is easier to test and debug during the smaller iterations, because first we only debug and test this part, then in testing for this module is done, then separate testing for this and this. So small part at the small module at a time is added. So it lowers the initial delivery cost and it is easier to manage the risk, because the product is small earlier with less features, but the major features are there. Then we are adding additional feature only. So the risk to handle the software is very less. Next. So disadvantages of the incremental model: it needs good planning and design, clear understanding and complete definition of the whole system before it can be broken down and built in. So clear in understanding of the whole system is required, so that you can break down into the different modules like module 1, module 2, module 3, module 4, module 5, and it requires the main expertise. It requires the main expertise here. So total cost is higher than the waterfall, but it is less than the prototype model. So here we complete with the which model? Incremental model, which is also known as the evolutionary model.